All right. Let's start out with just a couple announcements. There's a test next week. Are we having a class on Friday? No, there's no class on Friday. Because the second half of the day is going to be activities.
We're not able to play golf.
What's going on?
Our secondary teacher said we have to pass.
Yeah, she was like, you canceled congregating engagement. Did she come to you guys' like teacher meeting?
Yeah, that was not the information that I've been given.
So maybe she's
I'm
not.
trusting you because
Yeah, because I feel like you probably actually went not just her, but I would.
Yeah,
she's been teaching
let me
a lot longer.
just look at my email real quick because they've been sending emails about it. Yeah, as of 1:10 this afternoon, Mrs. Jorgensen sent out an email that said at 1:30, the elementary classes will have their parties and the upper grades will meet in the commons for treats and games.
Commons?
Oh
Or
wait, I just realized.
so we're not going downstairs?
This says commons. I don't know,
Sounds fine,
but
Yeah.
but not really.
I know. Wouldn't you rather be in chemistry?
Yeah. Yeah. Sure. Let's go with that.
So yeah, as of 1:10 this afternoon, less than an hour ago, the official email said no classes in the afternoon.
Okay, then I don't know where she gets her information from.
Anyway, so yes, we are going to finish out chapter 10 today, so that next week we can have first class of the week will be the review, and then we'll have the test. Okay, so a week from today will be the test. Your study guide will be up on LMS shortly, probably sometime either tonight or tomorrow. You will get a hard copy next week. So, anyway, so far in chapter 10, really what we've been doing is a bunch of math, right?
Yeah.
It's just been a bunch of unit multipliers. So for those of you that math comes easily, this has probably been a really easy chapter for you. For those of you who struggle with math, it may not have been quite so easy. That being said, these sorts of conversions we're going to be using for a lot of things throughout the rest of class. So if you are struggling with them, let me know so that we can help you. Okay. As I've said before, it's not me versus you guys. All right. I am here to help. Don't be afraid to come and ask for help. The people who ask for help do better. Okay. That's just the way it goes. So please don't be afraid to come and ask for help. All right. So starting into section 3 of chapter 10, moles of compounds. Okay. Now, to be completely honest, this is once again very, very similar. Okay. But instead of just single elements like we have been doing. Now we're going to start saying compounds. Okay. Now the math itself is not going to change. What's going to change is our conversion factor. Okay. So let's just go straight in and look at example problem 6 on page 334. Okay. So we've got aluminum oxide, which is often called aluminum. It's the principal raw material for the production of aluminum. Alumina occurs in the minerals corundum and bauxite. All of that interesting information has no relevance to what we're actually doing in this problem. Okay. So determine the moles of aluminum ions in 1.25 moles of aluminum oxide. Okay. So this one, pretty straightforward. It may not seem straightforward yet to you, but it is. Okay. So we're going to start with what we know. What we always want to do, start with what you know. The problem is going to give you information. Use it. Okay. So we're starting with 1.25 moles of Al2O3. Okay. Now, the question is asking, how many moles of aluminum ions? Okay. So our conversion factor, well, we know we need to deal something with moles of aluminum oxide. Okay. So if we have 1 mole of aluminum oxide, how many moles of just aluminum ions are there? You sure?
Nope.
Because you're right. You just, it was a very apprehensive 2. So I'll let you know. You know.
I mean, at least that's right.
Why 2?
Usually like 2 and not.
That should actually be 3. You guys are supposed to catch me when I make mistakes like that.
Oh, yeah, that's because he's free.
Oh, thank you. Thank you. Okay. So if we break this apart into ions, okay, that's what we have, right? All of these get put together into that. Okay? So for every 1 mole of these, we have 2 moles of those. So this becomes our conversion factor.
Does it become like the aluminum is +3, and then the oxygen is -2? So we need to like make it to be 0.
Yes. So, since this is our conversion factor, remember we can write it in 2 different ways. Or we put this over that. So one of these 2 things needs to get put right here. Which one?
Well,
Top or the bottom?
No.
Well, how do we decide? What determines?
Because you gotta get rid of the mole, right?
Well, there are moles on both sides.
Um,
So how do we determine what we need to get rid of? Aha, this time we need to get rid of this. This is the first time that we're actually going to be canceling out a compound. Up until now, we've only been canceling out moles or grams or particles. Okay. This time, we actually do need to get rid of this. So, do we choose the conversion factor with this on the top or the bottom? We choose it on the bottom because anything divided by itself is 1. So if you are multiplying by 1, does it change anything? No. So that means we can cancel it out. Okay. So we're going to choose this one because the aluminum oxide is on the bottom. So we have 2 moles for every 1 mole. So that mole cancels out. That cancels out. We're left with moles of aluminum ions, which is exactly what the problem asks for. Okay? And now all we need to do, well, I'd say put it in your calculator. You can probably do that math in your head. If not, put it in your calculator. I'm not going to blame you. Okay? So we take 1.25 times 2.
No.
2.5 moles of aluminum ions. Okay? So we're doing the same thing, but this time we've introduced the concept that you can get rid of a material. We can have an equivalency between 2 different types of things. Okay? So up until now, we said, okay, you have this many grams of gold. How many moles is that? We didn't change what we were working with. But we can use these conversion factors to change what we are working with. As long as you can set up something like this, you can change anything you want. Okay? You can change anything you want as long as you can set up an equivalency like that. Okay? Does that make sense? Okay. Now, we need to have a little refresher on molar mass before we move on. We've talked about this concept briefly. But it's been a little while. So we're going to do a little refresher. The molar mass of a compound. Okay. Well, let's start by remembering what is the molar mass of an element. How do we find the molar mass of an element? Like, what is the molar mass of oxygen?
15.999.
Okay. The molar mass of oxygen, well, you just look on the periodic table. Gives you your answer. But what if you need the molar mass of, say, water? Is water on the periodic table? No. So how do we find the molar mass of water?
Find the 2H and the O, like the mass of the oxygen and 2 hydrogen.
Okay. It's really pretty straightforward. We just add everything up. So a hydrogen, 1.00795, but we've got 2 of them. And then we add the mass of an oxygen. Okay. And that gives us our answer. Okay. It's just about 18. Okay. For most calculations, if you go with 18, that's going to be close enough. Like I've said before, it's good practice to be as precise as possible. That being said, plenty of chemists will round off if it doesn't affect the final outcome. So. But yeah, molar mass. Okay. We're going to be taking that concept and mixing it together with what we were doing in previous days. Okay. So none of these concepts are super complicated. Okay. It's just a matter of applying them correctly. And that can take some practice. Okay. That's why I give you homework, so that you can practice, so that it works out for you. Okay. Once again, if you're struggling on the homework, come see me. Okay. I sit here every study hall. Most of the time, I'm not really doing anything that important. In fact, if you come see me for study hall, you might be interrupting my game of solitaire or something like that. So don't stress, okay? Come see me. I'm happy to help you, okay? But practicing these so that you can see how these different conversions go together. Okay. Anyway, so let's combine this molar mass and what we were doing the last two classes. Okay. So if we look at example problem 7, the characteristic odor of garlic. So if you like the smell of garlic, this is what you are actually smelling. Okay. Is allyl sulfide. And it gives us the formula. So our formula is that. Okay. What is the mass of 2.5 moles of the allyl sulfide? So let's start with what we know. Now our conversion factor, if we're going from moles to mass, okay, so we want moles on the bottom and grams on the top. Because we want to cancel out this mole. So now we just need to figure out what we're going to put in. And really, what we want is, what is the mass of 1 mole? And how do we figure out the mass of 1 mole of this compound? We add everything up. Okay? It's just adding everything up. So what we need is, now this one, you got to remember there's 2 of these. Okay? So we need the mass of 6 carbons plus the mass of 10 hydrogens plus the mass of 1 sulfur. Okay? Does that make sense? You see why we're adding that up? Okay. We could go through and do the math, but it breaks down the math for us. This is on page 336. And we see they've calculated 114.21 grams per mole. Okay. So we're going to take this, I'm going to put it right there. Look, okay, it's literally the exact same thing that we've done. The only difference, instead of having an element here, you have a compound. So there's one additional step. Instead of getting this number straight from the periodic table, we have to do just a little bit of math. Okay? We add up what's in there. Okay? We do this. Once again, we could actually do the math if we wanted, but it gives us the answer here. 286 grams. Okay. It's the same thing that we've been doing. This is the third day of it. Okay. The third day of it, and we've just sort of been changing things a little bit as we go through. Okay. On 337, it goes the other direction, mass to moles. We've done that a whole bunch of times. Okay. Do you want to go through the example, or do you feel good about it? Because I'm happy to go through the example, explaining why we're doing what we're doing. But if at this point you say, this is the third day of it, I know what we're doing, we can move on. You want to go through the example? Okay. All right, let's go through the example. So in this example problem on 337, we're going mass to moles for a compound. Calcium hydroxide is used to remove sulfur dioxide from the exhaust gases emitted by power plants and for softening water by the elimination of calcium and magnesium ions. Calculate the number of moles of calcium hydroxide and 325 grams of the compound. Great. Start with what we know. We have 325 grams calcium hydroxide. The problem says, how many moles is that? Okay. We need moles here, and we need to get rid of grams. So what we're looking for in our conversion factor, 1 mole of calcium hydroxide equals how many grams? Okay. Well, what we need to do is find the molar mass of calcium hydroxide. So in this case, looking at our formula, we're going to take the mass of calcium off of our periodic table. I'm going to add that to the mass of 2 oxygens. It's an O, not a 0. Don't add 20. And 2 hydrogens. Okay. And just so you can see what we're doing. So calcium is going to be 40.08 plus 2 times, I'm going to round it off to 16 because that's what the book does, plus 2 times 1.008. Okay. So 40.08 plus 32 plus 2.016 And when we add all that up, we get 34.10 grams, which is then going to go into our conversion factor. So 1 mole is equal to 74.10 grams. Put that in there. 325 times 1. Over 74.10. Okay. Grams is canceled out. We do this math, and it gives us 4.39 moles of calcium hydroxide. Okay. We're bringing the units that haven't canceled out. Okay. The hardest part is figuring out your conversion factor and which way you're going to put it in. Okay. Like I said, if it hasn't clicked yet, probably need just a little bit more practice. Okay. So the next one goes mass to moles to particles. Okay. Now we can go through that, but really we can just add it onto this because we've already gone mass to moles. So for this one, how do we go from moles to particles? What number do we use? Yes, Avogadro's number. Okay, so our conversion factor is essentially going to be 1 mole equals 6.022 times 10 to the 23rd particles. Okay? Are we going to put mole on top or bottom? When we put it in there, are we going to put this mole on the top or the bottom?
Bottom.
On the bottom. Why?
Because the mole in the middle is top.
Because we need to get rid of this one on the top. So we put 1 mole, and then we put 6.022 times 10 to the 23rd particles. Okay. Okay. That cancels out. Now, what if it asked about something like individual ions? Well, we can actually take another step. Okay? Because we can put in there, in that conversion, that for 1 mole of this, we have 3 moles of particles. Does that make sense? 3, because there's 3 pieces that it breaks into. Okay. I don't think any of your homework gets that specific, and I'd never have put it that specific on a test because that's kind of a trying to trip you up question, and I generally don't like those. But yeah, just so you know, really it's just one more conversion factor. Okay. As I said, that's why I like these lines, because you can put as many things on them as you need and just get to your final thing. Okay. So that's the end of section 3. We're going to hit on a couple things in section 4. just, sort of quickly here. So section 4 is the first time that we're going to be doing something sort of different in chapter 10. Chapter 10 has really just been a whole bunch of unit multipliers. Section 4, where we get into empirical and molecular formulas. Okay. And it brings up this idea of percent composition. Now, I believe we may have hit on this at the beginning, but like we mentioned it and moved on without ever working with it. But percent composition. Basically, you can take a compound and figure out the percentages of these different elements in it. Okay. And the formula is right there on page 341. It's pretty straightforward though, if you know how to do percentages. So for example, let's just stick with something like water. Okay, if you wanted to know the mass percent, and this is, we do it by mass. If you wanted to know the mass percent of hydrogen in water, so we would take 2 times the mass of hydrogen divided by 18, because that's the molar mass of water. Of course, it's a percentage, so you have to multiply by 100. Okay. Take the mass of whatever element you're interested in, divide it by the mass of the total compound. Okay, multiplied by 100 because it's a percentage. This is pretty straightforward. Okay. We'll do this example problem though, just to make sure everybody feels okay about this. So this time we're going to be dealing with sodium hydrogen carbonate. So this problem is on 343. Okay. Now sodium hydrogen carbonate goes by a different name, baking soda. You're familiar with that. Determine the percent composition of the sodium hydrogen carbonate. So basically, we have 4 different elements. So we're going to have 4 different answers. And these 4 answers should add up to 100. Okay. So the first thing we need to do is calculate the molar mass of our sodium hydrogen carbonate. And the way we do that, we take the mass of sodium plus the mass of hydrogen plus the mass of carbon plus 3 times the mass of oxygen. Okay. We add everything up in there, which will give us 84.01 grams per mole. Okay. So now, to get our 4 different answers, we pick one element at a time. So for sodium, we need to figure out what is the mass of sodium in 1 mole. Okay. Well, that's just what's on the periodic table. Okay. So we take 22.99 grams per mole and divide it by 84.01 grams per mole. That whole unit cancels out. Percentages, if you have done them correctly, have no units. Okay? All of your units need to cancel out if you're doing a percentage. And then we multiply by 100. Okay? That gives us our answer, which, according to this, 27.37%. For hydrogen, we do the same thing, 1.008 grams per mole, 84.01 grams per mole times 100. Carbon, then oxygen is the only one that's a little different because we need to take our value that's on the periodic table, but we've got 3 of them. So we need to multiply by 3. 48. Okay. So we've broken it down into each thing. And then we get 0. And 57.14. Now, a good rule of thumb, add these all up to see what you get. Okay? So if we add all these up, okay, so 27.37 plus 1.20 plus 1430 plus 57.14, we get, okay, that's a rounding error. Okay. If you get something that's really close to 100, you've done it correctly. If you're not getting something that's really close to 100, you've messed something up in here. Okay. So I've decided that I don't want to talk about empirical formula. It's not that you can't get it. Just if I were to put it on the test, it would literally show up on this test and then it would never show up again. And so, you know, I'd be teaching it to you just so that I can put it on the test. So I've decided that I'm just not going to put it on the test. Everything else has an application further on. Chemistry tends to build on itself. And so, you know, but not that empirical formula is useless, but it's more useful when you are actually doing experiments in a lab. So instead of teaching it to you just so that I can say I taught it and tested you on it, we're just not going to do it. We're going to make your lives a little bit easier. So we're going to stop there. Of course, I do have some homework for you to fill out the rest of class. Let me just double check, make sure I didn't put any empirical formula questions on there that I need to take off before. So the homework will be this. can go ahead and get started on that. As always, if you're struggling, ask questions. It's one of the reasons why I let you get started on your homework before class is out, so that if you hit something where you're not sure about it, you can ask questions. If you hit something that you're not sure about while you're at home, send me an email. Okay. I can't promise that I'll respond within minutes, but I will get back.